Hello, welcome back to the series of lectures. Now we are getting into lecture number 15 in dynamics. We are working on friction. If you recall, I tried to first give you all static friction cases. Then I was trying to look at the minimum required force to just displace the body. And in that, of course, we saw a few horizontal cases and we looked at the disc and the rod and then a cone. Now we go to uh, inclined surfaces. I'm not very sure, but first I think let me look at the vertical surface. If this is accelerating with A and I'm placing a body here, of course this is N, the pseudo force is MA, this is mg, and this is FL. This just preventing it from, I think I discussed this case, N is equal to MA, FL is equal to mg, mu N is equal to mg, and mu MA is equal to mg, so that A is equal to G by mu. Now the idea here is that A must be minimum, or A must be greater than or equal to G by mu. Now that is important here, okay? Right. Now, if you recall the same thing in the horizontal direction, you are getting mu G, and there should be less than mu Z, it should be greater than G by mu here if you really compare those two cases, okay? Now, if I take a little beyond, we look at this is if you take it as fixed inclined surface and you have a body here. Now, as before, mg sine beta, mg cos beta, this is n, about to fall, therefore displace. So you got FL. So FL is equal to mg sine beta and n is equal to mg cos beta, but FL is equal to mu n. So mu mg cos beta is mg sine beta, mg gets cancelled. Tan beta is equal to mu. Now this beta, when it is, the body begins to slide down on its own, that angle is called angle of repose. Incidentally, we will call it as tan theta. What is theta? Minimum angle at which the body begins to slide down. Begins to slide down. And we know mu is nothing but tan theta f. Therefore, angle of friction and angle of repose are numerically one and the same, but technically these two are two different quantities, remember, okay? So what you require is that it should be angle of repose. Now what do you mean by this? Now, for example, If theta, beta is less than theta, f is equal to fs is equal to mg sine beta. If beta is equal to theta, f is equal to fl is equal to mu mg cos beta is equal to, just now we did it. But if beta is greater than theta, f is fk cos beta. But you can't equate fk to mg sin beta. Okay? What happens then? This is mg sin beta is more, fk is less. So the body will accelerate down. Okay? That also I will deal with that a little while from now. I hope this is clear to you now. This is the most simple of all the cases. Right. Then, supposing I take this and subjecting this. You recall we have discussed this in the case of static friction also. It's small m, this is capital M. This is rough, this is smooth. So no complications, this is going. Now, when does this body sleep down? Condition for body to just slide down. What do we do? V, so pseudo force mv, normal force, mg, mv cos beta, yes, as usual you know that this becomes and it should be prevented from sleeping, therefore Fn. Suppose they ask you, you should prevent it from sleeping up, then Fl will be downwards. In this case, what do you get? We will see here. What do you get? mg sin beta is equal to mb cos beta plus Fl. Fl is mu n, and n is equal to mg cos beta plus mb sin beta. Okay? Got this? Relative, therefore this is at rest and all that. So two equations you get from this, and this, if you draw this, be careful while drawing FBD of the inclined surface. The Fl is here like this, so the reaction will be like this. You see, Fl upwards, reaction downwards. N in this way, therefore N in this way. These are all the interactive forces. Okay? And you say this is going with the B on the other side. Now this is your N dash, this is your capital MG. we have virtually got all the terms. So this is n sine beta, n cos beta. Now, what equation do I get in this direction? In this direction, FL, this is FL cos beta, FL sine beta. How do you write? Horizontal equation is important for us. In this direction, minus opposite is equal to mass into acceleration of that body B. Okay? Alright? I am giving an acceleration B here. The B is known to me. I may use even capital F also. That's another problem, you can do it. So that I'll put a F like this, F plus FL cos beta minus n sin beta is equal to MB. So I'll do that. I mean, F for you. Let me apply a force capital F there. Because of that, the acceleration is B. Then you have F plus FL cos beta. I hope this is clear to you. You have a body here, right? I'm pulling it with a force capital F, and supporting is FL cos beta, opposing is n sin beta. So you are getting this equation. So F is known to us, all right? Now, okay. So AR is 0, therefore I have taken everything. Now you substitute. Supposing if I substitute n in this, let us see what do I get. Mg sin beta is equal to Mv cos beta plus mu into all this. Mg cos beta. Don't get confused with the lengthy expressions that you are getting. Retain B on turns onto the one. So I think M is everywhere. On this side you have B into cos beta plus mu sin beta. And if you bring the rest onto this side, G into sin beta minus mu cos beta. So, B is equal to G into these are all not for your memory. Every time you are given a problem, start writing down immediately on your own, then you will get all the answers perfect. Now you can further simplify this dividing with cos beta numerator, denominator, therefore this becomes tan B. This becomes mu. This is 1 plus. What do you mean by this? If this acceleration is less than this, then the body will slide down. So, for the body not to slide down, for body not to slide down, B minimum is equal to all this. G into tan beta minus mu by 1 plus mu tan beta. B minimum, right? And once you get the B minimum, you can substitute in this N and this F also you will get. I'll give you that also here for you. What is F, suppose if I am asking you? Now you bring this onto this side. FL is mu N. So N into mu cos beta minus sin beta, I think as is equal to mg so n also. What is n? You remember? mg cos beta plus FL sin beta. So this is what you have to substitute. Where am I getting? Is it FL? No, not FL. This is mg cos beta plus mv sin beta. Okay? So F is equal to N. N means all this. Mg cos beta plus mv sin beta into this sign is reversed. Sin beta minus mu cos beta is equal to, equal to, I already put it, plus mg into this is the thing. Okay? This is B. So what I'll do is, first I'll separate the terms. Mg cos beta into sin beta. So one term is over. What is the other term? Minus mu mg cos square beta. These terms. Now look at these two. Plus mb sin square beta minus mu mb sin beta cos beta plus all this I'm writing for the time being as mb. Alright, okay. Mu mb sin beta cos beta mg. So now you can see G, I think I will take only B terms and retain them as they are. mg cos beta sin beta. Okay, these two plus B. What is this? M sin square beta plus capital M, this minus mu m sin beta cos beta. Right. And For BME, you have to substitute this. So I can write, I think somewhere you have to have this B minimum G into tan beta minus mu by 1 plus mu tan beta. Okay. Now substitute all this here. Mg cos beta, mg cos beta, you have sin beta minus mu cos beta plus B, you can write all this G into the whole thing m plus m sin square beta minus mu m sin beta cos beta. This is the F minimum value. You have to simplify this. I'm only giving it for the sake of completeness. You can still write this in terms of your sin beta minus mu cos beta as before and still work on the whole thing, and you can write a simplified relation as this is, we call it as F minimum. You understand this point? This is F minimum. What should be that B minimum? Now, what is it I am trying to? I'll give you a recap. Don't worry. Here, what I took, I am applying a force here so that it is going with an acceleration B. I don't want the body to slide down. Therefore, your answer is B must be greater than or equal to this one. Okay? That's all. As simple as that. You just want to get F. I think all this paraphernalia you have to do. I hope this is clear to you now. Don't get confused with all these complicated expressions. You need not memorize. You need not remember. But if you want how to get, you should know. So I can even further simplify that also. I wish you do now. I think this is sin beta minus mu cos beta. This is common. So likewise you can take and then maybe further if you can simplify, I think that would be better. If you want, I'll do it. Fine. This is the B value. Now you got this point. Now if I write the whole thing here as sin beta minus mu cos beta by cos beta plus mu sin beta. This is what I divided numerator denominator. So why I took that? Because this is common between the two. So what do I write? Sin beta minus mu cos beta, and in these two G is common. So G, the whole thing I removed, the whole thing I removed. So what do you get? We will write here. Okay? On this you write m cos beta plus all this sin beta cos beta whole divided by cos beta plus. You see what are you getting? Now m cos square beta, m sin square beta, that becomes m cos beta, mu m sin beta minus mu m sin beta gets cancelled. So what are you getting here? This gets cancelled, this becomes m. You see how simplified this is? G into Sin beta minus mu cos beta by that's it. This is your F minimum. Unless you apply with such a force of this minimum, the body would tend to slide down. Okay, that is fine. So far, so good. But as I said, in the case of friction, you cannot end up with relations of this nature just like that. But you have to develop the other side of the coin. What if I take F to be much more? The body would still remain stationary. And the stage will come, the body will tend to slide up. At that instant, this is the FL. So, minimum force for body say the body not to slide up. You increase it. What is that maximum? If you go beyond, the body would slide up. So maximum force, or I may say, what is B max? Either way. So I've already got mg cos beta, mb sin beta, mb cos beta, sorry. This is mg sin beta, mg cos beta. So you have n is mg cos beta plus mg sin beta. And this is balanced. Therefore, you have FL plus mg sin beta is equal to mg cos beta. What is FL? Mu n plus n, all this you substitute, n mg cos beta plus mb sin beta, mg sin beta. Now I'm just looking at the other case. We will take all b factors onto one side. Mu mg cos beta plus mg sin beta I retain. Take everything onto the other side. I think m cancels everywhere. You have cos beta minus mu sin beta. So what do you get? As I said, can so g into mu cos beta plus sin beta by cos beta. This is B max. What is this? B max is G divided with cos beta, then what do you get? Mu plus tan beta by 1 minus mu tan beta. Now, if you put mu is equal to 0, you will get that our original smooth surface, what is the minimum acceleration to prevent the body from slipping? Got B is equal to G tan beta, you get the same in both the cases. The moment you bring in friction, you get the range of values for which the body is stationary. What is the range of B for the body to be at rest? At rest with respect to incline, remember. Okay? What should you do? B must be greater than or equal to this is the one, or less than or equal to mu plus tan beta by. Do you recall? In the case of cone, we got this. In the